or good morning, or whatever the sun might be doing wherever you are. Most people that watch my films are from the States, so it's probably morning over there. So, this video is about the octave, the nature of the octave and what the octave means to me, and what it means in regards to the research and the development of these telepathic machines. The octave is a curious thing. As above, so below. As above, so below is basically saying reflections above are similar to the reflections below. The octave is, in physics and music theory, a note or a string or a wavelength that is either doubled or halved in frequency or length. So, an octave of, for example, 1 meter, the octave above 1 meter would be 2 meters, and the octave below 1 meter would be half a meter, or 0.5 of a meter, or 500 millimeters. So double or half, that's the octave. Double or half, double or half. That's all it is, but there is more to understanding it. So the Planck length is the beginning of this dimension. The infinitesimally small, whatever that word is, very small length, and it's not usable unless it's scaled up to the sizes we can physically play and fabricate with. So, the basic concept is that the universe, and I'm going to try and explain this in a metaphor because it's a little hard to explain the specifics of this in this video. It will be covered in other videos, but quite simply, the emotional and physical integrity of a length is kept if it's doubled or halved. So the Planck length has a specific value, which was stated in the previous video. That is doubled and doubled and doubled and doubled up until the point in which it becomes usable. It's past 100 octaves. It's around 100 octaves is what is used in the machine. It's above 100 octaves. I'll make it very specific in the next video. The octave, 2 specific octaves of curiosity and usability. So I won't give away that right now, but the next videos will cover the 2 areas or the 2 octaves required or most useful for creating the machines and why. So basically, the Planck length, as I mentioned earlier on, has a specific set of values, specific frequency, specific angle, specific density, all related to this one length. But the one Planck length is only the source. The idea is this: you need to basically split the length up to give a specific modality. So you don't actually ever, and this is what's so interesting, you don't use the Planck length to run a machine. You use it in the machine, but you don't use it to run the machine. The only mode which you cannot use to run a machine is the fundamental mode, because that is responsible for all other modes. It is like the master. It is like the one single. So the only machine that you don't build is the one that is in unison with the Planck units, because they're quite simply all jammed up with every possible mode ever in existence. It's like a junction that is way too fiery and too hot and too active to actually be used for any practical purpose other than just spewing energy into another dimension or bridging dimensions or something like that. So you don't really focus on that. But what I'm saying is the way that you get modalities from the octave or the Planck length is by dividing it, is by adding and dividing. So you could have, for example, 1 Planck length divided by 2, which is still unison. And this is what I was trying to get at with the explanation of this video, is that it doesn't matter if it's doubled or half, it is still the same. So anything doubled or half is mathematically in this arena the same. It will always default to whatever octave you've assigned because it's the same. It is the same value. So say if you divided the Planck length by 3, which is one of the universal modalities, one of the first universal modalities, you will get a specific angle, you will get a specific wavelength, you will get a specific wave number, you'll get a specific frequency and a specific density. And that will be all covered. But by doing that, you have created a modality from the source, something which is individual. And once you've assigned that modality then becomes an octave too. So that can be doubled and half, and it will always have the same attributes. So it's like the universe has personality, and you can see this personality and empathize with it by viewing color, because color is length. And we'll get into the next video, I'll get into how color and length are related, and where the fundamental color, or the color that is related to the Planck length, is how that's calculated. And so you can see the personality of every modality because you can see its corresponding color by simply viewing the octave of color which matches the octave that you might be manipulating. So for example, color is in the nanometers of diameter when it comes to wavelength, but the actual wavelength in the machine is much larger than that. It is in there between, universally speaking, most machines would have a wavelength between 10 and 30 millimeters. And there's a very specific reason for that, but that's kind of the range. It's in fact more accurately between 13 and 26 millimeters approximately. So I'll explain why that is also. So we have these octaves. We have the Planck length, which scales all the way up to color, and it keeps scaling all the way up to usable wavelengths inside the machine. And so it doesn't matter what modality you choose, the octave has the same integrity and the same functionality. It also has a personality, and you can understand that only by viewing its equivalent color and empathizing with what that feels like. And I know that sounds bizarre, but that's it. That's how all this works. It's very much all interconnected. And this is where it starts, leading down the path of telepathy and how that plays into all of this and the universe. So the variance between the length, say if this was a Planck length and this is its octave up, double Planck length, so 1 Planck length, 2 Planck lengths, the distance between the first and second Planck length is the modality. That differential between one Planck length and two Planck lengths, that distance between the 1 and the 2 are where all the modalities in between exist. And every possible combination in the universe can exist between that first and second length, because that's all it is. It's literally like a dial on a radio, and it keeps going up octaves and down octaves, but it is only the distance between the primary length and the octave above it. So say if you had one Planck length and a second one is the distance between the first and the second, or the second and the fourth, etc., etc., etc. That differential is assigned by an integer modality, which is basically multiple Planck lengths divided by multiple wave numbers, and you get different modalities, different personalities, different functions, different logic, and different systems, different places they all tune to. So it's very curious, but the primary length is not enough. That's the fiery source of everything. You divide that into a modality and you use that. You use whatever modality you've chosen. And there are literally infinite, but there is only a few near the source, which are practically easy to make. Relatively easy to make. So in the diagram that I'll be putting up now, expresses the octave in the form of a cube, which is used to understand how to calculate the density inside the machines, which is quite simply, and will be further explained in other videos, the Planck mass with inside a cube, and each side of the cube measures a Planck length, and that is how you derive density. That is how you scale it up to this tangible size. Because as the cube increases in size, the density decreases. And the pressure is less and less and less. Hence why you can actually scale that using the vacuum, and miraculously enough, it is within scalable range. When you scale it all the way up to the millimeter range, it is accessible and within range between the pressure on the surface of this planet and the vacuum. It is within that, easily achievable, which is very cool. But that's all to be covered further. So also in this diagram, you will see the octave represented as circles, halving and halving and halving and halving and halving, all the way down to the Planck length. So it doesn't scale down to infinity, it has a beginning. And in these diagrams, the Planck length is the beginning, and it just doubles and doubles and doubles and doubles up to the point in which the octave you've chosen in order to assign the default wavelength that you're trying to manipulate, so to speak. So the circle, I can't see the diagram right now, but the circle represents angle and frequency. The cube represents density, mass, and volume. Those are the main units we're using, so those are the ones that will be covered. So that's essentially the nature of understanding the octave in this work. When we do the calculations, sometimes if the calculations are between the unit 1 and 2, if we're using a ratio, for example, so you've got 1 Planck length, 2 Planck lengths, and the ratio in between that, for example, would be, if the Planck length would be divided by 3, the ratio would instantly be assigned not 2.33333, but 1.33333, because what we've done is doubled that number so that it is in between the octaves of 1 and 2, just to make it easy to understand. So that is just what my mind has been programmed over the years to understand, but most people might be a bit confused about that in regards to doing the calculations. But it always, because it's an octave, it will always default to any place on the octave. However, when you're doing the final calculations, the density octave is what actually locks it in, and that cannot be changed. If that is out of range, or you cannot access that pressure, or there's too much, or the vacuum's too high, or there's too much pressure, there's nothing you can do about that, because that's what assigns everything. But for doing the calculations, in order to understand the harmonics of a machine, you can choose any octave, because it will always equal itself. It will always be the same modality, regardless of what octave it's in. It will always be the same. So that's pretty much the overview of the way that I understand octave, the nature of octave in this work, and how it is essentially a building block of understanding how the machines work, because it is used all through the machines, and strongly suggestive that the universe recognizes the position of the octave much more strongly than the octave itself. It recognizes the specific modality you're using more than which octave you've chosen, which is assigned anyway. So both are assigned, the modality and the octave, but the modality has much more impact in how the mathematics is affected inside the machine than the octave itself. So until next video, adieu.